the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And let there be light. And there was, and God divided the darkness.
And God called the light day, and the darkness he called night, and the evening and the morning were the first day.
It is Christmas Eve. Borman, Lovell, and Anders circle the moon. It is the greatest voyage of discovery in the history of man, taking them 231,000 miles from Earth. And their thoughts turn to the creation.
And God called the dry land earth, and the gathering together of the waters called he seas. And God saw that it was good.
We stand on the threshold of a great new age of exploration. Its ultimate destination, the furthest reaches of the universe. Its goal, the innermost secrets of the cosmos, the key to the very creation of that universe. Unthinkable? Perhaps. But only a dozen short years ago, it had been unthinkable that man would ever orbit around Earth or circumnavigate the moon, let alone land on it. What has happened in the decade of the 60s has been so incredible. Come with us then and observe the views from space of the Earth and the moon and beyond. What is in the heavens? Who is in the heavens? For 1,000 millennia, man could not hope to know, for he was imprisoned on a tiny dot on a distant edge of a minor galaxy in a universe of unknown vastness. Then came Sputnik. In a single moment, man had reached into the heavens. In the scant dozen years since Sputnik, man has gone to the moon, seen it in its starkness, and described it.
Actually, I think the best way to describe this area is a vastness of black and white. Absolutely no color.
The moon looks a very whitish gray, like dirty beach sand, and with lots of footprints in it.
Don't these two craters look like pickaxes striking concrete, leaving a lot of fine haze dust?
And there was one heavenly body no man had ever seen before in all its majesty, for he had never left it. The Earth. Now that man is preparing to leave his Earth for the solar system, a new breed of explorer is being trained. Scientists. Among the first of this new breed who will establish scientific stations on the moon and beyond is Dr. Harrison Schmitt, a geologist. Now, geologist Jack Schmitt awaits the challenge of the moon.
For a geologist, or actually for any scientist, or even any person with a proper training to get his hands on this thing, we are actually having a chance to handle, to study, to read a record of the Earth's past, which we have no chance to see in the Earth.
The challenge of space for Americans was voiced in 1961 by President Kennedy.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
President Kennedy's challenge and dream will undoubtedly be met, but the cost has been staggering. $36 billion in one decade, involving the imagination and dedication of more than 250,000 men, and the lives of 3, Grissom, Chaffee, and White, who died in a tragic fire caught in a capsule on its pad while training for an Apollo mission. From these sacrifices in treasure and blood were to come a new perspective of our Earth and beyond. We will view this new perspective as our astronauts have viewed it. In space, a complete orbit around Earth requires some 90 minutes. Our voyage of about an hour will follow this route. Across the Atlantic, through the Mediterranean basin and North Africa to the Nile and the Middle East, into Asia at Iran, over India and the Himalayas to China, across China to the Pacific, and via the Hawaiian Islands back to the United States. In space, our earthbound concepts have no meaning. Time, night, day, even up and down as we pitch, roll, and yaw. In space, all is silent. We are far above the roar of storms and ocean. We are 60 miles up now. Below, the hazardous, light-colored reefs of the Bahamas, where Columbus searched for his new world in the faith that the earth was round. See how the generations pass, like sand through heaven's blue hourglass. We fly over Cuba and Guantanamo Bay, site of the American naval outpost. Past the steep, dark mountains of Haiti now, where Columbus touched land in 1492. Our spacecraft heads over the North Atlantic, eastward, on our voyage of discovery. As past and present merge in the views from space, so do the white clouds seem to be a part of the land and water. In space, the capsule seems to have expanded. Without gravity, we can float everywhere. This is how the men of the Apollo 7, Schirra, Cunningham, and Isley, experienced it, moving like swimmers in a sea of weightlessness. Below, the Canary Islands, once thought to be at the end of the flat world, and ahead, our first continent, Africa. On the main Canary Island, a 12,000-foot volcano is seemingly lost from 100 miles up. Gibraltar, in a funnel of clouds, gateway to the Mediterranean Sea, with Spain, Portugal, and France on the left, and Italy in the distance. The heartland of Western civilization in a single view, fulfilling a dream of Socrates. We who inhabit the earth dwell like frogs at the bottom of a pool. Only if man could rise above the summit of the air could he behold the true earth. The northwest coast of Africa, great continent where man became man a short million years ago. And now, from the edge of the Mediterranean, springs the true desert, the vast Sahara. This is almost all of the Kingdom of Libya, 680,000 square miles of North Africa. Captain Lovell remembers the Sahara.
For miles and miles, that's all you could see were the sand dunes. And the way that the wind had put the dunes in a particular orientation, it was quite an amazing sight. This gives you a good idea of why the geologists like to get pictures from space, because it gives them a complete overview of the ground, the terrain, and it shows them things that airplanes or just ground observation just doesn't give.
Below the prize of many conquerors, the vast triangle of the Nile Delta, its lush, irrigated land dark against the desert sands. 90% of the United Arab Republic lives in this maze of branches from the mighty Nile. History has traveled these waterways. Here, Joseph prophesied the 7 fat years and the 7 lean. And here at the river's edge, Moses was found, and from here he fled. Cleopatra and the pharaohs ruled over this delta. Cairo, a gray blotch at the narrowing of the delta. 4 million people live there. Up from Cairo, we can see the Middle East, cradle of 3 religions. In one panoramic view, Egypt on the left, the Sinai Peninsula on the right. Israel, Jordan, Syria, Lebanon, Turkey, and Cyprus.
I gave this picture to a Israeli officer some time ago, and at the time I told him it was an oblique shot of Israel, and now it's an overhead shot.
That's right, the real estate has changed hands.
The Sinai Peninsula, a wedge of desert between Egypt and the Holy Land. This was the wilderness where the Israelites wandered for 40 years, and where Joseph and Mary took flight into Egypt with the infant Jesus. And now from Cairo, up the historic Nile. Time is a river of passing events, said Marcus Aurelius, and strong is its current. No sooner is a thing brought to sight, then it is swept by, and another takes its place. And this too will be swept away.
Could you believe the Red Sea? The Red Sea? Yeah. Right now, we're viewing the Red Sea.
Upside down. You can
upside down? Well, the spacecraft is upside down, but the world is upside up. Right side up.
Along the Red Sea, Africa is on our right and Arabia on our left. Once in a small spot along the coast was the kingdom of Sheba, whose legendary queen traveled for months northward to Jerusalem and King Solomon. From space, most of her route is seen in one glance. But it is more than beauty and history that man's new views from space reveal. From them are coming new visions of what our future can be. At the Department of the Interior in Washington, Gemini, Apollo, and unmanned satellite pictures are being studied to see just how much they can uncover of future sources of raw material and food for man. The director of the Geological Survey's Earth Resources Programs is Dr. William Fisher.
You know, we've looked at many, many ways in which space would help us just as a nation. And I'm convinced that the greatest benefit of all will come in the educational field. And I often like to think about this very famous Gemini shot of the Nile Delta and recall that when I first saw this picture of the Nile Delta, I couldn't help but be struck with the thought, I didn't know it looked that way. The city of Cairo can be easily seen in the lower part, and the major transportation networks throughout the Delta. Of particular interest, however, are the myriad of villages within the Delta that appear as gray spots. On this map, each of these villages has been identified, and there are over 1,000 villages seen in this one picture. One of the most important pictures obtained in the early Gemini flights was a picture of a part of the Arabian continent near the Gulf of Oman. A geologist looked at it, and within a matter of hours, he had created really a very fine geologic map of the area, identifying the different rock types, showing those areas that were covered with drifting sand and would be not amenable really to modern exploration techniques. And by golly, every Gemini photograph that we've looked at has given us information which we think will accelerate our discovery of natural resources.
Already, the views from space are revealing things man never saw before. For years, photogeologists like William Trollinger of Denver have searched for oil and gas deposits by piecing together aerial photographs. But with space pictures, Trollinger can see what hundreds of photos from airplanes could not capture. 4 pictures made on Gemini and Apollo flights have covered most of a vast area of West Texas and New Mexico known as the Delaware Basin. And surprisingly, traces of the deep substructure can be seen. The Delaware Basin is rich in oil and gas trapped along underground cracks or fault lines. The basin is set like a tilted dish, most of the fault lines buried miles below, with only the western rim of the rocks above ground, topped by El Capitan Peak.
When we first saw the space photographs, we found out that we had been looking through a glass darkly, interpreting all of this collective evidence, this minute detail, which is necessary for any proper geologic investigation. But when we found the space photograph, we found we can see the big picture, the major structures, and how they relate one to the other. It's been said that it can be likened to a fly walking on the face of the Mona Lisa, and it's not until that fly lifts off and looks back till it knows what it's been looking at.
Space photographs are becoming another tool in our search for new energy from our own planet. This is just the beginning.
For petroleum and natural gas, the value, I believe, will be incalculable. While we're studying the moon and all of the wonders of its surface, I think we need to turn around and take a look back at the Earth. I think the value of space photography is immense.
New sources of energy, new sources of food. From this space photo made from Gemini 4 in 1965, a great new promise comes to fishermen along the Florida Keys and better understanding of ocean currents. What has the sweep of the seas to do with feeding the world's growing population? Just watch.
That door's jammed right yonder. Hey, go on. Hey, George, right now you got some buoy behind there. Get on this buoy here.
Shrimp processing is the largest seafood industry in the United States. In season, scores of small boats dot the Gulf of Mexico and Atlantic waters, groping with their nets for where shrimp used to be, ought to be, or just might be. It is tough, bone-tiring work, and as the demand for shrimp has grown, methods to increase the supply have failed.
Help him there, man.
There is a vast area of the Gulf known as Upper Florida Bay, which looks ideal for shrimp to grow in, but they do not. Some said that the waters actually caused baby shrimp to die. One Gemini photograph dispelled the myth, showed how the ocean currents swept baby shrimp from their spawning grounds into Lower Florida Bay, but not into the Upper Bay. Dr. Robert Stevenson of the Bureau of Commercial Fisheries.
In this photograph, we see a large eddy, some 45 miles in diameter, which peels the water off from the Florida current into the Florida bays, and by this mechanism we realized why the shrimp or how they came into the bays.
So the view from space revealed that the ocean current was the villain of Upper Florida Bay, and work has now begun towards seeding the upper bay with young shrimp. Pregnant females caught in the fishing grounds are brought to the laboratory where they live until they release their hundreds of thousands of eggs. When the baby shrimp reach the post-larval stage, they are siphoned out of the tanks and experimentally planted in the waters of Upper Florida Bay. After a matter of weeks, they will begin migrating to deep water, increasing the potential catch. From one space photograph has come the prompt to a nursery and greatly expanding the sources of food. Happening here can occur in many other areas of the world. Off the waters of Asia and Africa, there are potential spawning grounds for shrimp and other sea life, if man can only see them from space. In the years just ahead, for the views from space will be to help men solve the problem of hunger by understanding the sea. The sea and the land. In the past, aerial photographs of the United States have been taken by the thousands. A coast-to-coast map of the nation from aircraft would take 10 years and $12 million. But in a single test, a Gemini spacecraft provided the basis for a photo map of a wide area of the Southwest in 10 minutes. Now being tested for satellite use are new cameras and other sensing devices from airplanes. What may we see in 1970? Well, for one thing, we could begin to map water supplies from melting snows. This photo shows what appears to be a huge glacier here in white. But with infrared photography, much of the glacier proves to be snow-covered vegetation, dark shades. Views like this from space could help provide us with more accurate water estimates. Or look again. Think how a census of crops could benefit an overpopulated world. This photo gives information for such a census. This is a field of cotton seen on the aircraft's infrared film. Due to poor irrigation, some of the cotton is sickly, providing a smaller yield. Number 1 shows healthy cotton. Number 2 is poorly irrigated. Nothing grows in number 3. A space watch could reduce disaster to crops. This infrared picture shows a wide swath of dead trees at the top, threatening the entire forest. Early warnings could cut the annual $20 billion crop loss in the United States alone. The view from space can be a window against other disasters. This is a part of central China, often ravaged by flood and famine. Through space sensing, such inaccessible regions could be monitored. Many details can be made out by experts from this space photograph: the conditions of the roads and railroads, the rivers and flood areas, farms, and erosion.
The whole program is really geared to benefit the average citizen of this country and perhaps of other countries as well. It's his dividend, I think, for the expenditures we've made in the space program. It'll mean more food, it'll mean adequate water, good clean water. It'll mean that he will have the recreational resources that he needs to enjoy life when we have more leisure to enjoy. So we have an obligation to explore and to develop, and space can help us do it.
The world lies at our feet, 22,000 miles below. Much of it unknown. Its riches waiting to be discovered with views from space. In space, time passes strangely. Day becomes night and night day, as if we are passing through tunnels. Captain James Lovell.
The sun seems to come up quite steadily as it does. We can see the colors along the horizon from quickly in a deep blue to a light blue to perhaps a pink as the rays bend slightly around the Earth. Of course, it's all black right above it. And suddenly the sun just pokes itself above the Earth horizon, and then it's a brilliant white. And as a matter of fact, you don't want to be looking just prior to sunrise at that area. You want to be looking away from it a little bit because the sun is so brilliant.
The steep mountains of Iran lie beneath us. Hidden behind the mountain barrier are the ruins of one of the great cities of the ancient world, Persepolis, capital of the Persian Empire, destroyed 2,300 years ago. Colonel Borman.
In space, of course, there are no winds. You don't have the drift problem you have in airplanes. So really, you can put your orbital marks on this map, and just by time, you can mark off the time and say, well, I should be over Calcutta. And you look down, and there's Calcutta.
Not only Calcutta, but the whole subcontinent of India lies 600 miles below. 1 million square miles from her tropical south to the northern mountains facing Russia and China. Colonel Aldrin.
If you look close, you can see some of these very uniform lines that convinces you that man's down there, and he's made his mark on the planet that is visible from 160, 180 miles.
Now the frozen roof of the world, the Himalayas, tallest mountains on Earth, which for centuries have challenged man's endurance, yet insignificant from space. 9 of the world's 12 highest peaks are in this one view. K2, or Mount Godwin Austen, over 28,000 feet above sea level, lies below. The dark patch in the center is Mount Everest in perpetual winter, 29,000 feet tall, highest mountain on Earth. We're only about 1/2 from our starting in Florida as the spaceman flies. We are crossing from India into Tibet, on our way toward the heartland of central China. We will cross China from west to east, following her meandering rivers just as men have done since recorded time. We trace the Yangtze, longest river in Asia, from her source past Chongqing, Wuhan, and Nanking. Shanghai in the Yangtze Delta at the upper left. We move freely along the China coast over the ports of Fujian, Hong Kong, and along the Tonkin Gulf toward North Vietnam. Below, dotted by clouds, North Vietnam. Before 1957, neither man nor anything man-made was in space. Since then, the United States and the Soviet Union have launched some 3,000 objects, most of them unmanned and American-made. They have traveled out as far as Earth, past Venus. Some have been in center atmosphere. Some will continue traveling for 1,000 years. They have looked out and they have looked back, sending to us new knowledge of the Earth's magnetic shield and gravity, the sun's radiation, the composition of the moon, Mars, and Venus. To conceive such complex tasks, to design and build their hardware, men had to devise entirely new approaches to the very question of problem solving, with incalculable values to other problems here on Earth. Many innovations have already come from space. For industry, new metal alloys and long-life power sources. For medicine, new means to monitor the human condition. 2,500 technical developments. And we have just begun as we approach the moon. The moon seemed the only way it could be seen a short decade ago. Yet by the mid-1960s, we achieved our first close-up view as the unmanned Ranger spacecraft televised its pictures back to Earth before crashing into the moon's surface. Next, a Soviet and then an American vehicle landed softly on the moon and scanned the strange scene. Our Surveyor spacecraft televised the surface and dug beneath it. We knew then that the moon could sustain the weight of a future manned spacecraft. Several lunar orbiter satellites then circled the moon, and while searching out the best locations for manned landings, sent back these most dramatic and vivid views of the lunar landscape. One lunar orbiter televised back a unique portrait from the moon, an Earthrise, with the Earth glowing as it reflected the sun's rays in the blackness of space. New views of the moon. New views of the Earth. Communications satellites have been carrying telephone and television signals between continents since 1965, and soon some 50 nations will be linked by them. Perhaps the family of spacecraft immediately affecting the greatest number of Americans are the weather satellites. Our various meteorological vehicles keep daily watch on the world's cloud cover, increasing the accuracy of weather forecasting. It is estimated that only 10% more accuracy in predicting weather could save $2.5 billion annually for farmers and industry in the United States. Weather satellites have proven their worth through advance warnings of storms, whose habits are then studied for the future. One classic case was in the great hurricane of September 1967. Here we see a yet unnamed tropical disturbance when a weather satellite first located it far out in the central Atlantic on September 1st. For the next 6 days, the storm is tracked by the satellite as she heads westward. Then by September 8th, the disturbance has become a full-fledged hurricane. Warnings are flashed throughout the Caribbean and beyond about the hurricane, now named Beulah. On September 10th, Beulah brushes past Puerto Rico and the next day lashes the Dominican Republic. The weather satellite continues dogging the hurricane's heels. Between the 13th and the 14th, south of Jamaica, Beulah picks up speed and races toward the mainland. A top priority emergency warning comes some 20 hours before Beulah strikes the Texas coast near Brownsville. After a 24-hour rampage, the storm moves on, leaving $1 billion in damage and some 300,000 people homeless. Yet the advance warnings have cut the toll in human life to 41. Thanks to the view from space. Other space views are helping provide us with security. ABC News science editor, Jules Bergman.
Both Russia and the United States have large and very active space reconnaissance programs with satellites that use both television and film cameras. We launch our recon spacecraft into polar orbits so that Red China and Russia are visible beneath them in daylight hours every day. What they have discovered since we started launching them regularly in 1963 has saved America untold billions of dollars in unneeded armaments and possibly prevented a war based on miscalculation of an enemy's strength. The spy satellites are mostly called SAMOs, for Space and Missile Observation Satellites. They first uncovered Red China's growing nuclear strength. The birth of Russia's new nuclear-powered, missile-equipped submarines was also closely watched. One fantastic picture taken last year, none have ever been released by the way, spotted more Soviet nuclear submarines being built in 1 yard on the Baltic than were being built in all the American shipyards. The alarm bell rang. Russia had a sub that was faster and deeper diving than many of ours. It was found out in time, and faster, deeper diving U.S. subs have now been given the go-ahead. How is this done? As our recon satellites orbit the Earth, quick-look shots are recorded on videotape by TV cameras, then broadcast to ground stations in California, Alaska, and elsewhere as the satellite passes overhead. Higher quality pictures are made with film and returned periodically to Earth in camera capsules, which are retro-rocketed out of orbit. This film sequence shows a blazing capsule ejected from a recon satellite. Although these motion pictures show recovery from a satellite other than Samos, the technique is identical. Special aircraft flying out of Hawaii and other Pacific bases search out the camera capsule, which has now released a parachute to slow its descent. Special equipment is put into place behind the plane, ready to snag the capsule. And the recovery is made. What can be seen? The following examples approximate real recon pictures shot from aircraft and spacecraft. Against the sun glitter on the ocean, here can be seen ships' wakes, viewed from an airplane in this case. The ships are long since gone, but where these two wakes come together, a submarine and its tender had rendezvoused, and by the use of infrared and other photographic methods, we can determine their speed and whether they are nuclear powered. There are fewer places to hide each day. This is Fort Worth and Dallas, a wide stretch of Texas filmed by Apollo 6. Carswell Air Force Base with Strategic Air Command B-52s on the runways is clearly visible. Even small planes can be counted. The methods used are highly classified. This is a shot from a not very advanced recon camera being tested to see how well it would pick up the enemy in Vietnam. Now the close-up of the same shot. Clearly picking out a parked truck, its identification, and its driver. Even if there were a forest canopy obscuring the scene, new sensors and cameras could have found it. In a little notice speech last year, President Johnson paid tribute to space spying. More than enough billions have been saved, he declared, to pay for the entire military and civilian space programs.
And now, on the last leg of our voyage across the Pacific, we see yet another view from space. Colonel Buzz Aldrin leaves the capsule on EVA, extravehicular activity, in training for flights to the moon. We see what he saw and hear how he felt.
You would think that now as you open the hatch to exit the spacecraft that you might want to think of which way is up and down relative to the Earth. But that's not true at all, because all of your attachments and your handholds and everything that you're interested in is right there in that spacecraft, and you really don't care where the Earth is, except perhaps if you're taking some pictures. There's absolutely no concern at all about any falling tendency toward the Earth. Fantastic is the best way to describe it. Looking through the window from inside tends to frame your view, but when your head is out in space, it just seems as though it's everywhere and you're there right with it.
The coral atolls of Micronesia, heading toward Hawaii.
This the Hawaiian island chain. You can barely see the light atolls down here.
Buzz said he saw a few grass skirts here, but I don't believe it.
Well, you can see Diamond Head. Don't you see it?
Our EVA ends. We streak toward the United States.
See smoke come offshore down here.
Well, there obviously can't be any intelligent life down
No. Who'd be dumping that sort of stuff in the atmosphere?
The clouds have broken, and there's Los Angeles under its man-made cloud of smog. We head inland over the Salton Sea toward Arizona, New Mexico, and Texas. We are completing our first orbit. There's the mouth of the Mississippi River. Ahead, the Florida Peninsula, where we began. We are to pass over Cape Kennedy again, and then out to sea. Our return to Earth begins. Captain Lovell.
The first thing that happens is really nothing. You're still up there, coming down, and then suddenly the heat shield starts hitting the upper atmosphere, and the sky takes on sort of a pinkish color. The gases are starting to ionize. And then you start feeling the effects of gravity. About the time you're pulling about 3 Gs, the ablative material, of course, is melting away, and it's coming off in big chunks, and the ionization has turned green. It's a green gas now, and you can see the flames out in front of you as you come on through. This holds about the same all the way down until you go subsonic. And suddenly there's a big rush of sound because you can hear all the noise now coming through. And from then on, it's a very pleasant ride.
At about 10,000 feet, the parachutes open, slowing our return through the atmosphere. For a very brief moment in time, man has touched the periphery of the universe. He has seen his planet as it has never been seen before. The view from space is staggering. But 2 questions remain. Was it worth it? If so, where do we go from here?
No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space. And none will be so difficult or expensive to accomplish.
We will meet probably this year. Men are already walking on a simulated surface of the moon. But with all we need to do on Earth, will a trip to the moon have been worth it? Dr. Athelstan Spilhaus, president-elect of the American Association for the Advancement of Science and head of Philadelphia's Franklin Institute.
I think that we have to review our priorities on our expenditures of money and see if it isn't more important to spend our money to bring human living in humane surroundings and human values to the people who are on Earth before we go overboard on programs out in space. And I think that this can be as great an exciting experiment to try to abolish the misery of our poor, and particularly the blacks, as exploring space. But I would not want us ever to get to the point where we spent everything on the immediate problems and didn't look to the future, not only in space, but in basic research and in the things that are also necessary for people.
Dr. Wilmot Hess, director of NASA's Science and Applications Division.
The question of what do you do after you have gone to the moon, the first thing I would say is you go to the moon a second time. You are given the opportunity of understanding another major body in the solar system, and in doing that, probably to understand something about the origin of the solar system and something about other objects in the solar system. I don't know how to put a price tag on that, and I'm sure to the people who are strongly interested in this area, they would say that the program was worth that.
Dr. Bruce Murray, chairman of the Department of Planetary Sciences at the California Institute of Technology.
That part's all for free. It's very tough to say where should we go after the moon. A lot of people have worried about this. Some would like to use these big boosters and do very big things, like send a man to Mars. I think a more sober view, as well as a more economic one, would say that man's role in space after Apollo should be on his own merits. If he's that important to the operation of a complicated instrument system, then fine, we'll pay the penalty in weight and in survivable equipment for him. If, on the other hand, he can be really just nothing but a passenger, or maybe even a basket case, we don't want him. The most exciting missions of the 70s and 80s, I think, the ones I think that the history books will be writing about, are the first close-up looks at the more distant planets. We've had a close-up look at Mars, enormously surprising discovery of the fact that it looks like the moon rather than the Earth, and that all our previous ideas were wrong, were filled with misconception. I think the same thing will happen if we get a close-up look at Mercury. A close-up look at Jupiter, which is such an enormous thing, can't help but be exciting. The satellites of Jupiter, which are as big as the moon itself, are totally unknown. And finally, by using the massive gravitational attraction of Jupiter itself as a slingshot, we can fire ourselves out into the very depths of the solar system, to Saturn, Uranus, and Neptune, and look at the whole totally unexplored area in the solar system for the first time. These are the historic milestone missions, I think, of the 70s and perhaps the 80s.
Extending its beauty beyond the horizons, space, in all of its strangeness, stands as a challenge of our time, a test of our boldness and also of our wisdom and responsibilities to one another here on Earth. In the final analysis, the question is not, will man extend his view from space? The question is simply one of priorities, of timing. Not will we, but when will we? For all of man's staggering achievement, the stars today are but little closer to his grasp. We will reach the moon, perhaps the planets. After his incredible voyage around the moon, Colonel Borman, addressing a joint session of Congress, put it this way.
Exploration really is the essence of the human spirit. And to pause, to falter, to turn our back on the quest for knowledge is to perish. And I hope that we never forget that.
This has been a presentation of ABC News.